So today we're going to talk about properties of definite integrals, and we're going to look at this function to understand all these properties that I'm going to go over. So this is the function f, and this is going to be the left endpoint, which I'm going to call a, and this is going to be the right endpoint where we're going to stop the integration at b, and then we're going to let c be some point in here in between. So like right here, that would be c. Okay, so it just c is in between a and b. All right. Okay, so what we know, okay, is if we want to integrate this, if we want to find the area, we're going to integrate from a to b and f of x dx. Now, when we did the Riemann sums and the summation notation, the sigma notation, and all of that, we always did b minus a, right? And we did the right endpoint minus the left endpoint, and then divided by how many there were, and that was our delta x. So that's still going to be the case. Our delta x, which then, because we were taking the limit as in went to infinity, that delta x became my dx, right? Okay, so delta x is still b minus a divided by n. All right, so this is one of the first properties that we're going to use a lot of, okay, on the homework, and it's this one. It's the order of integration. So notice we're starting at a and we're going to b. That's how we read it, right? But if you look at this one, they've switched. So now we're going this way. So now what happens is to figure out what this integral is, our delta x now becomes a minus b, which will become a negative value, okay? It's the same area, but because we're going in reverse, it's going to cause it to be negative. So what happens is this is going to become, we can still figure this out, but what it would become is the negative of the integral from a to b of f of x dx. So let me talk a little bit about this, okay? A little bit more, because this is probably the hardest one to understand, I think. So this f of x is my heights, right? And for right here, if I integrate from a to b f of x, okay, because I'm starting on the left and ending on the right, my delta x's are all going to be positive, okay? Because I'm taking a bigger value minusing a smaller value. So this right here is going to be positive. And my function is going to be positive because it's above, right? So that means this is going to be positive and this is going to be positive. And so when I multiply, I'm going to get a positive value. All right. However, this same function, if I go on this, my delta x now becomes a minus b if I flip it, and then this becomes negative. My function is still going to be positive because it's still taking place right here. So in order to get this, it's going to be the opposite of whatever the integral is from a to b. That's what this says, okay? That's the hardest one to understand, I think, okay? So this next one, the zero property, okay, is if we integrate from a to a. So if we start it here and end it here, well, there's no rectangles to be made, right? Our delta x is going to be 0. So if we integrate from a to a of f of x dx, that's always going to be equal to 0, okay? So that's going to be a really significant one, and so is this one going to be today, okay? And there's going to be a couple that aren't as significant, okay? And I've actually already gone over this one earlier when we first started to learn about indefinite integrals. If we integrate from a to b, k times fx, so this is a constant, so this is like 5 or something else, we could rewrite this as 5 times the integral from a to b of f of x dx. So we could find just the integral from a to b of f of x dx and multiply it by 5, and we would have this. This is just a special constant where it's -1, so this becomes negative the integral from a to b f of x dx. All right. And then here we've already talked about this one. Okay, we talked it with indefinite integrals. These are definite integrals. So if we're adding or subtracting two functions, right, and we're integrating the sum and difference of those two functions, this becomes the integral from a to b of f of x dx, plus or minus, depending if we're adding or if we're subtracting, and then the integral from a to b of my second function, g of x dx. Okay. All right. So let me zoom out a little bit because I want to refer to the graph up here. Okay, this is going to be another one of the ones that's going to be important today. Okay, if we want to integrate, if we integrate from A to C, so that'd be this integral right here. If we have that area right here and we add the integral from C to B, that would be this one. In essence, that would be equivalent to the integral from A to B of f of x dx. Okay, so this idea is this is a part, this is a part. If we add the two parts, it's going to equal the whole. So that's a mathematical idea that's not just in calculus, but it's used a lot. That if you take a part of something and add another part, you're going to get the whole. If you add all the parts together. Okay? So I want you to understand that you can manipulate this, okay? So you can move one to the other. So this is the whole, and these are the two parts. So if I move this to the other side, we can get a part. So if we need to find the integral from C to B of f of x dx, that could equal the integral from A to B of f of x dx. And we've moved this one over, so it's going to be minus the integral from A to C f of x dx. And in essence here, what we have is the part is equal to the whole minus the other part. Okay. And then you could move it around so you have another one too, right? We could get this one by itself. So if we have the integral from A to C of f of x dx, that would equal the whole, which is the integral from A to B, the whole thing from A to B, f of x dx. And then minus, well, we're trying to find A to C, and we have A to B. We just need to subtract C to B, right? So this would be the integral from C to B of f of x dx. So if we take the whole and we remove this part, what we'd be left with is this part, okay? And so this is, again, part is equal to whole minus the part. I'm going to tell you for the problems I do, I like to just write it as this part plus this part equals the whole, and then figure some stuff out and then manipulate it and move it back, okay? And then solve for the integral that I'm trying to find. You'll see in a minute, okay? Okay, this I'm going to tell you right up front. I'm going to be honest with you. You're not going to use this today. I'm doing this next page and these two properties, the max min inequality and the domination one, because we're going to need this for what we're going to talk about on Friday, okay, or the next day. All right. So right here, all right, this is an integral. This is a function up here. Okay, so we could point this out. This is a function, f of x, and so we could get the shaded region by simply taking the integral from A to B of f of x dx. And that would give me the shaded region, okay? Now, this one is a rectangle, all right? And we could get this rectangle. This would be, this length right here would be B minus A, and our height would be f of A. So this would be f of A times B minus A. Okay, and in this case, our A, right, this f of A is actually the minimum of this function, okay? So f of A, that's going to be important. F of A is a minimum. Over here, f of B is the maximum, right? And it didn't, the f of A happens to be on the left endpoint, but it wouldn't have to be. It could be anywhere in here. Okay, anywhere in between A and B is where the minimum could happen. All right. This one right here, all right, is, again, this is a rectangle, all right, and this length right here would be B minus A, and this height would be f of B. So the area of this rectangle would be f of B times B minus A. And so f of B is a maximum. All right, so what we just discovered, if f of A is a minimum, okay, this integral is going to have to be somewhere in between this, because this isn't enough area and this is too much area. This is like the three little bears, okay? Too little, too big, just right, okay? So our this integral right here, this area right here, is somewhere in between the area of this rectangle and the area of this rectangle. And that's what the max-min inequality says, okay? So max-min inequality on the interval, so on the interval A to B, okay? So if we take the minimum value of f of x, so min of f of x, whatever that might be, all right? And we multiply it by b minus a, that area that we get here from the minimum value for the function has to be smaller than my integral. So this is going to be less than or equal to the integral from a to b f of x dx. But this integral is going to have to be smaller than this rectangle because this is way more area, right? We have all of this up here that we're including. So this integral is also going to have to be less than or equal to the maximum of f of x times b minus a. So the integral has to be somewhere between the minimum value times b minus a and the maximum value times b minus a, okay? Because this is the area of the big rectangle and this is the area of the smaller rectangle, and so our integral has to be somewhere in between. Okay, so now let's talk about domination. All right, so f of x. If f of x is greater than or equal to g of x, so it's the function f of x is going to be bigger, right, above g of x, okay, on the closed interval a to b. Okay, what that implies is that if the function, if f of x is higher and we're going from a to b on both of them, then that would mean the integral from a to b for f of x would have to be larger than the integral from a to b for g of x, right? Because f of x is going to give us bigger heights for our rectangles, okay? So that's all this says. Domination, since this function's bigger, the integral is going to be bigger on the same interval, okay? So on this interval, the integral from a to b, f of x dx is going to have to be greater than or equal to the integral from a to b of g of x dx. Similar to this is, and we've actually already used this, if f of x is greater than or equal to 0 on a to b, which means the function is always going to be above the x-axis, right? And we've already said this, if the function is above the x-axis, then when we go to take the integral on this, then that means the integral's going to have to be positive, which means it's also greater than or equal to 0. This is just a special case of this one where g of x is 0, okay? So here we go. So what this is telling us is that the integral from a to b of f of x dx is going to have to be greater than or equal to 0. So it's going to have to be positive or 0, okay? And the only way it's going to be 0 is if f of x is 0, okay? All right, there's our properties. Now I'm going to show you how we're going to use these, okay? And that's what I'm going to do the next examples. Okay, so let f be a continuous function such that the integral from -3 to 4 of f of x dx is equal to -6. So we know this integral. And the integral from -6 to 4 of f of x dx is equal to -9. And we're trying to figure out what is the value of the integral from -3 to -6 f of x dx. So notice something right off the get-go, right? These are the wrong order, right? This one needs to be smaller than the upper limit. So this is called the lower limit, and this is the upper limit. This in this case, this upper limit is smaller, right? So in that essence, we're instead of integrating from making our rectangles from left to right, we're making them from right to left. And so we don't want to really do that, okay? So I'm going to lay out a strategy that I use for this, okay? Is I like to kind of create, to help me understand everything, is to create a number line with all the lower and upper limits. So of these, -6 is the smallest, okay? So I'm going to create a number line right here. So let's say right here is -6. Okay. And then the next one would be -3. So -3 would be there. And then 4 would be somewhere right here. All right. You can do this other ways. This is just the strategy that I use to help me. Okay. So I know I'm going to integrate from left to right. So I know from that additive property that if I integrate the integral from -6 to -3 f of x dx plus the integral from -3 to 4 f of x dx, I know that's going to have to be the same as the integral from -6 to 4 f of x dx. Now, if you look at this, I know some of these, right? I gave you this one right here. I know this one. This one's -6. And I also know this one. This one is -9. So I'm going to make a substitution in here. Okay, so -6 to -3 f of x dx. And then I'm going to add this one, which is adding -6. So I'm just going to write -6 is equal to this integral from -6 to 4, which is -9. And so what I'm going to do is I'm going to add 6 to both sides, okay? And then I'm going to have this integral. So the integral from -6 to -3 f of x dx would be -9 plus 6, which would give you -3. Now, that's not what I'm trying to find, right? Okay, but what is this one going to be? Well, I know that if I take the integral from -3 to -6 of f of x dx, I know from the very first property that I talked about that I can change the order, right? The order of integration. I can change the order by taking the negative of it. So I can switch these, but then I'd have to put a negative in front. And that's what I'm going to do. So I'm going to say, okay, this is equal to negative the integral. And instead of going from -3 to -6, I'm going to switch the order. So it's going to be -6 to -3 f of x dx. Okay, now I know this one, right? I know this one's -3. So that means this is equal to, I'm going to come off to the side here, negative of -3. So that makes this equal to +3. So now I know the integral from -3 to -6 f of x dx must be 3. Okay, and that's how you do these. Okay, and we're gonna do a lot of these. Okay, and I'm gonna give you like these statements, and I'm gonna give you other statements too. Okay, and I'm gonna give you graphs, and we're gonna use these properties a lot of different ways. Okay. Okay, so I have the graph of f, and I want to find this integral from 4 to -3, and I've given you the areas of all these regions here. Okay, so I want to find what is this integral from 4 to -3 f of x dx. Now, what do I need to do? Well, I need to find this. I can do what I want to do is I want to switch the order of integration. So instead of going from 4 to -3, I want to go from -3 to 4. I can do that as long as I switch this to negative. So negative of the integral from -3 to 4 of f of x dx. So now it's just a matter of finding this area, right? So this is going to be equal to negative of whatever this integral is. Well, I'm going to start here at -3, and I'm going to go from -3 to -1. And because it's below, that's going to be a negative value. So I know that's going to be, since the area is 7, this integral from here to here would be -7. And then from -1 to 1, I know that's +6, so +6. And then I'm going to go from 1 to 4, and then that would be ending at 4, right? Because I want to just go from here, from -3 to +4. And so this part is also below, so I'm going to subtract 8. Okay, so that gives you negative of, and this would be -7 plus 6 would be -1, minus 8 would be -9. And so negative of -9, and so this turns out to be +9. All right, and that's how you do it. Okay, so for this next one, okay, and I should say this, the regions A, B, C, and D, they're not labeled up here, okay, in the figure. This is region A, this is region B, this is region C, okay? and the x-axis, the area of each enclosed region are labeled in the figure and their respective numeral values, okay? Find all x-intercepts. So we're finding x-intercepts. So that would be -7, -3, 1, or 6, okay? So that's gonna be, those are my choices for answers, okay? Find all x-intercepts b for which the integral from -7 to b of f of x dx is equal to 0. Okay, so this isn't going to be a lot of work. We're just going to look at this and go, okay, one of the properties that we're going to use is that if you integrate from a start to this and end it at the same point, that's always going to give you 0. That's that 0 property we talked about. So one of these could be right here at -7. So b could equal -7. Are there any others? There is. Okay, so if we start to integrate here, we get -9. And then, because we got to start the integration right here at -7. So if we go to here and stop it here, that'd be -9. But then I'm going to add 9. And so these two are going to cancel each other out. So at x equals 1, these two areas are going to cancel each other out. And so another value that this would happen at is at if b was 1. So b could be 1. So right now we're at an area of 0, and then I'm going to add 18. And if I add 18, okay, to that, then this one won't do it for me, right? If I integrate from -7 to 6, these would cancel out, and I'd have an integral of positive 18. Okay, so there's two values to this: b equals -7 and b equals 1. Okay, so we want to integrate from -7 to 7, all right? And we're going to integrate the absolute value of f(x). Now, what we have to realize is this is the graph of f, not the graph of the absolute value of f of x. So recall that the absolute value of f of x is the graph of f of x with all the parts that are below the x-axis gets reflected over the x-axis, okay? So this reflects all points below x-axis over x-axis. So this part that's below, right, is now above, okay? And this part right here that's below would now be above. Okay, so if I go to integrate -7 to 7, the absolute value of f of x dx, all right, that means this part, which for graph of f is below, is now above. So this would actually be positive 10 plus, then we're going to go from -4 to 0, and that would be, it's above, so it's going to stay above, so it'd be 17. And now we're going to go from 0 to 2. This part's below, but under this operation of absolute value of f of x, this part's going to get flipped over. So now this is going to be positive 4, so plus 4. And the integral from now 2 to 7 is positive 17. And so both of these, that if we were actually to do the integral of f of x, would be negative. Now they become positive, okay? So this would be, I'm going to try to do this in my head. 17 and 17 would be 34. This would be 38. So this winds up being equal to 48. Okay. Now I want to talk about what does this mean, okay? All this means is we're going to take the absolute value of whatever this integral is, okay? Because this is different than the last problem. It's not the absolute value of the function. It's actually the absolute value of the integral, okay? So if we take the absolute value of the integral from -4 to 2 of f of x dx, okay, that's going to equal, and the absolute value of, and we're just going to start integrating, okay? So from -4 to -2, this would be -8, right? Because we're doing f of x, right? This part that's below would be -8, okay? So -8, and I'm finding this integral, okay? And then I'm going to take the absolute value of it. And then from -2 to 0, that'd be +8, so +8. And then from 0 to 2, that would be -5, so -5. So that makes this equal to negative 8 plus 8, that'd be 0 minus 5. So this would be the absolute value of negative 5. And why? Because the integral from negative 4 to 2 of f of x dx is negative 5. So now I'm going to take the absolute value of it, and the absolute value of that would be positive 5. And that would be the answer to this one. All right. Okay, so now for this one, okay, we're trying to want to find the integral from negative 4 to 7 of 1/2 times f of x. So 1/2 is a constant. So I'm going to write this negative 4 to 7 1/2 f of x dx. Okay, and what this is going to allow me to do is take this 1/2 out. And so I'm going to write 1/2 times the integral from negative 4 to 7 of f of x dx. Okay, and now, all right, because of that, I'm using that property that you can pull a constant out, is this is going to be equivalent to 1/2 times, and all I'm going to do is find the integral. So I'm going to go from negative 4 to negative 2, that would be negative 4. And then from negative 2 to 0, that'd be plus 3. And then from 0 to 3, that'd be negative 12, so minus 12. And then from 3 to 7, and that's where I want into that, I'm going to add 15 to this. So this is going to equal 1/2 times, and this would be negative 1, and this would be that with negative 12 makes negative 13, and negative 13 plus 15 would make positive 2. And so this would equal 1. Okay. All right. Okay, so we have one more to do. So for this problem, I am giving the integral from 6 to 2 of f of x dx equal 9. I'm giving the integral from 6 to 9 of f of x dx is equal to 6. What is the value of the integral from 2 to 9, okay, of f of x plus 4? Okay, so again, because I'm not given a graph or anything, what I would do is I would start ordering these, okay? So the lowest values of these is 2. So we have 1 at 2, and then we have a 6, and then 9, right? And so we want to find this, the integral from 2 to 9, right? All the way across, but we're not given that. We're giving parts, right? We're given 2 to 6, okay? Actually 6 to 2, right? So what we want to do, okay, is we want to integrate, okay? And we want to go, what is the integral from 2 to 6 f of x dx plus the integral from 6 to 9 f of x dx. And I know that's going to equal, if I go from 2 to 6 and 6 to 9, that would give me the integral from 2 to 9, right? So this would be the integral from 2 to 9 f of x dx. Okay, so now what I need to do is, I know this one is 6, right? So I'm going to put a plus 6 here. Okay, I can switch this, right? Because I don't know 2 to 6. What I know is 6 to 2. So I'm going to switch this by putting a negative in front. So this is going to be negative, and I can always change the order. And this would be the integral from, instead of 2 to 6, it'd be the integral from 6 to 2 of f of x dx. And then that's going to equal the integral from 2 to 9 of f of x dx. Because I'm trying to get over here to this 2 to 9, right? I want an integral from 2 to 9. Now, I know 6 to 2, right? That's 9, right? 6 to 2, the integral from 6 to 2 is 9. So that makes this one negative 9 plus 6 is equal to the integral from 2 to 9 of f of x dx. And if you want to switch sides with this, that'd be okay. All right. So now this is telling me the integral from 2 to 9 of f of x dx would have to equal negative 3. Okay, so now we got to figure this one out, right? So the integral from 2 to 9 of f of x plus 4 dx, because this is a sum, right? I can use that addition, sum and difference property which means I can break this up. This would be the same as the integral from 2 to 9 of f of x dx plus the integral from 2 to 9 of 4 dx. And this one I know, right? I know this one because I just figured it out, right? This is -3. So this is equal to -3 plus, okay, so how do you find the integral of a constant? Now remember, graphically, this is a horizontal line, right? Y equals 4 is a horizontal line. So it's a line at y equals 4, and we're going to integrate from 2, to 9 somewhere out here. That's going to make a perfect rectangle, right? The width would be, or this side length would be 7 because we're going from 2 to 9, right? And this would be 4. Now, a way you could get that is we're going to have 4. That's the height of it, right? So 4 times, and we did this the other day. Okay, so we can do, how do we get this 7? Well, we get it by taking the 9 minus the 2. Right? That'd be this length, and the height of the rectangle would be 4. So this would be -3 plus, and then this would be 4 times 7. That's 28. So this is -3 plus 28, or that makes 25. And that's how you solve this problem. Okay, this one's one of the harder ones, and that's why I saved it for last. Okay. All right, that's it. You have an assignment on Delta Math that involves a lot of these properties, okay? And that's it for today.